We're going to look at using Excel to do some predictive analysis. We're going to set up a predictive model for our factory. And in our factory, we make three types of products, A, B, and C. And depending on the quantity of each of those products is dependent upon how much it costs to run the factory. So we've collected this data over the course of 19 months. And we're going to use linear regression to do the predictive analysis. Now, in linear regression, we have multiple independent variables. And the independent variables that are in this model are the three products we create in our factory, A, B, and C. Those are the independent variables. What's the dependent variable? What is dependent upon those three variables is the cost of running the factory. So the dependent variable in this case is the factory cost. So when you look at the regression equation, the multiple regression equation, you will see that what we have is an equation for a straight line. And we can assume in this example and all the examples in this course, MIS 204, that there is a linear relationship. So that's why we're using an equation for a line. So where do we begin in building our predictive analysis model? Well, first of all, we need to make sure that the regression tool is loaded. And we go click on Data in the tab. And when we click on Data, we see Data Analysis is loaded. Well, how did we get that loaded? Go over to File, click Options, click Add-ins, choose Analysis Toolpack, click Go. Make sure Analysis Toolpack is checked. We're not using Solver in this particular instance, so we can uncheck that. Click OK, and the Toolpack is loaded. So let's click on Data Analysis. And when we click on Data Analysis, we have all of these different statistical functions. But the one that we want to use for predictive analysis is regression. So click on Regression, OK. Now this dialog box comes up, and it's very simple to do multiple linear regression in Excel. The first thing we want to do is we want to select the Y range. And the Y range is our dependent variable. So we'll select our dependent variable. Cost is dependent upon the products that are made in our factory. The X range, we have multiple independent variables. In this case, we have X1, 2, and 3 denoted by products A, B, and C. Perfect. And if you noticed, I've included the column labels. And we're going to have the output range. Let's put the output range on the same sheet so we can compare side by side the different outcomes. And we'll put the output range right there. Well, let's move it over one so we don't interfere with our formula. And that's it. We'll click OK. And Excel does most of the work for us. We see down at the bottom we have the intercept, and the intercept will be the constant in our formula. And we have the coefficients for each of our independent variables, which are listed there. But before we do anything, remember, we always need to inspect the p-values or the predictive values of each of our independent variables. And any predictive value that is 0.15 or greater, we're going to exclude. 0.15 or greater says that the predictive value of that particular independent variable is such that it really doesn't matter in predicting our outcomes. It is not of significance. So when we look at the p-values, we see for product A, the p-value is 0.23, which obviously is greater than 0.15. So we will exclude using the values for the independent variable for product A. Product B and product C both have p-values well below 0.15. So their predictive value is much, much greater. So at this point, we need to rerun the regression, excluding independent variable A. So let's go ahead and do that. Going to go up here, run the regression one more time, and instead of selecting A, B, and C, this time we're only going to select B and C. Why? Because we evaluated the p-values and found that A's p-value, the predictive value, was just simply too low. So there we go. We're going to run it again. We're going to put it on the same worksheet. Let's put it down here, right below it. And let's click OK. And we'll scroll down and look at the p-values. Now that we've gotten rid of independent variable A, the p-values, the predictive values of the other independent variables, have fallen significantly, and they have very, very strong predictive values. So at this point, all we need to do is take the different coefficients, plug it into the formula, and do our prediction. So how do we do that? Well, first of all, let's look at the line formula. The constant is the intercept. The b and x, the b values is what we're looking for. So in this case, we are predicting the monthly cost for our factory if we make 1,200 Model A's, 800 Model B's, and 1,000 Model C's. Well, remember we excluded A, so we don't have to include that in our formula. So let's go write our formula, plugging in the variables, and predict our cost. So again, beginning each Excel formula with the equal sign, equals the constant, and now I'm reading left to right here, the constant, which is the line intercept, plus, I'm excluding A because the p-value was too low, 800 times the coefficient plus 1,000 times the coefficient for C, and that's it. So let's press enter and make our prediction. And there it is. We can predict that if we may, given our historical data from 19 months, that if we made 1,200 Model A's, 800 Model B's, and 1,000 Model C's, it will cost $45,149.21 to run our factory. There it is, using multiple linear regression to do predictive analysis.